Okay, part 5D. Let g be a differentiable function, so we're not talking about f anymore. So g is differentiable such that g of pi over 2 is 0. The graph of g prime, which is the derivative of g, is shown here. Find the value of this limit, or state that it does not exist. I'll be very honest. I think I could have solved this problem on a multiple choice, but on FRQ I probably would not have earned all the points. I just would not have remembered to do everything that was required. Basically, to find the value of the limit, we've got to, x is not approaching infinity, so we can't compare terms that are adding. We can't factor and divide because we don't have a formula for g. We don't have a formula for g. So I just have to try the limit. I've got to think of values of x that are close to pi over 2. So I've got to say, okay, when f is close to pi over 2, I'll have close to e to the pi over 2 multiplied by close to the cosine of pi over 2. The cosine of pi over 2 is right here at the top. To hit that spot, we do not go across. We only go up. So the cosine of pi over 2, this here is 0. So when x is getting very close to pi over 2, the value of f will be getting very close to 0. When x is getting close to pi over 2, well, we know when x is exactly pi over 2, g is 0. And here's a part I don't think I would have noticed. Because g is differentiable, therefore g is continuous, which means when we get close to pi over 2, the value of g is also 0. So we're trying to find a limit, but we end up with 0 divided by 0. When trying to find a limit, if we end up with 0 divided by 0, we have to use L'Hopital's rule, which means we have to take the derivative of the top and the derivative of the bottom. So we're trying to find the limit of this, f prime divided by g prime. I think I could have figured that much out. I just don't know that I would remember to write things like, oh, the limit of f is 0, and then because g is differentiable, the limit of g is also 0. I don't know that I would get that point. I think I'd get the green point because I would have created this new limit problem. The derivative of f, let's see, f prime. Oh, we've already done that because that was done earlier. We had a formula for f prime. So we could go back to our f prime formula right here and plug in pi over, well, not pi over 2, but close to pi over 2. When x is close to pi over 2, we've already determined this is going to be 0. This will be 1 when x is close to pi over 2. So therefore, the limit's going to be e to the pi over 2 times negative 1, which is what they showed here. When x is close to pi over 2 for g prime, the y value is definitely getting very close to 2. That's why this is the value of the limit. I think I could have earned that point as well, so I probably would have gotten 2 out of 3. I just wouldn't have had the other details necessary to get 3 out of 3.